students, welcome back. In this lecture, we are going to discuss some previous year IIT-JEE question, which is very much important for the examination point of view. This will help you to analyze the IIT-JEE question from the concept point of view. So let's get started. Hello students, welcome back. Now we are going to solve some IIT-JEE previous year questions from gravitation. So let's get started. Question number 1. If the radius of the earth were to shrink by 1%, its mass remaining the same, the acceleration due to gravity on the earth's surface would be. So this is the IIT-JEE previous year question 1981. So here we have to comment on acceleration due to gravity on the earth's surface. So on the earth's surface, G0 is equal to Gm by R E square. This is the radius of the earth. M is the mass of the earth. According to question, radius of the earth is decreasing. So radius of the earth is decreasing. Okay, by 1%, and its mass remaining the same. So mass is constant and G is already constant. So if R decreases, denominator decreases means overall increases, that is G0 increases. So the here answer is G. So whenever radius of the earth decreases and the mass of the earth is constant, then the acceleration due to gravity at the earth's surface would be increase. Okay, now go to the next question. The numerical value, next question is, the numerical value of the angular velocity of rotation of the earth should be what? We have to find this. We have to find this angular velocity, means omega of the earth. Okay, in order to make effective acceleration due to gravity at the equator equal to 0. So we have studied already previously variation in acceleration due to gravity due to rotation. So at the this was the case. This is the earth, this is the equator, this is the pole. So at any position mass, so this is the mg F gravity, and this is F centripetal. So at equator, this was the theta. So at equator theta is equal to pi by 2. So G dash equator is equal to G0 minus omega square R. That is here sine pi by 2 is equal to 1. So G dash is equal to G0 minus omega square R. So effective acceleration due to gravity would be 0. So this is the 0 according to question. So that's why 0 is equal to plus minus omega square R. So omega is equal to G0 by R under root is equal to under root 9.81 divided by 6400 into 10 to the power 3. Don't forget to put these values in SI unit. Okay, so calculate this omega. It will be 1.24 into 10 to the power 3 10 to the minus 3 radian per second. just go and calculate it. Okay, so next question number 3. If the distance between the earth and the sun were half its present value, the number of days in the year would be. So we know that this is about time period and the distance. So we know that time period is directly proportional to a to the power 3 by 2. So t1 by t2 is equal to a1 by a2 power 3 by 2. So new t1 is equal to, previous one is 365 days, okay, is equal to current. What was the current? The distance between the earth and the sun were half the previous one. So previous one is a2. So previous one is a2. So a1 is equal to, since t2 is directly proportional to, when t2 it was 365, it was half of, now a2 is equal, now a1 is equal to a2 by 2. Okay, so it's about a2 by 2, a2 3 by 2. So a2 cancel. Now t1 is equal to 365 into 1 by 2 to the power 3 by 2. So it will come in out 129 days. So this is the answer. Now go to the next question. Okay. The geostationary satellite orbits around the Earth in a circular orbit around radius this. Then the time period of the spy satellite orbiting a few hundred kilometers above the Earth's surface will be. So same question, previous one. T is directly proportional to a power 3 by 2. So T for what? T for spy. Okay, spy by T for geostationary, it was 24. Okay, so equal to a for spy. How much? It's around just above the Earth's surface. So 6400 into 10 to the power 3 by, it is how much? 36000 into 10 to the power 3 power 3 by 2. Since t is directly proportional to a to the power 3 by 2, so spy corresponding to spy radius. The radius of a spy is, according to question, the spy satellite orbits a few hundred kilometers above the Earth's surface. So we can take it as just it is on the Earth's surface. So we are taking R. Okay. For geostationary satellite, 24 hours is the time period and this is the radius. So calculate T S pi is equal to, it will come approximately 1.7 hours. So since according to question here, T square is directly proportional to a to the power 3 by 2. That is, if a increases, then t also increases. According to question, a is greater than r earth. That is, t spy also greater than 1.7 hour. That is 2 hour. This is the answer. Okay, so next, a body is projected vertically upward from the bottom of the crater of the moon at depth r by 100. So this is the moon, this is the center of the moon. Now this is the depth of the crater r by 100. So this is total distance is r. So r minus r by 100 will be the this distance. Okay. Now from here, from A, the body is projected with escape velocity, okay, on the surface of the moon, equal to the escape velocity on the surface of the moon. Calculate maximum height attained by the body from the surface of the moon. So now just it is about conservation of energy. So just conserve the mechanical energy. Initially total energy is equal to K plus P, and initial kinetic energy is equal to half mu. Okay, potential energy will be this. Okay, here you can put u, this u. Okay, so this will be minus gm by 2 aq. aq, what it is? It is radius, so r. q bracket 2 r q minus, okay, what is the r? R is this distance, okay, 99 r by 100. So 99 r by 100. Okay, this is V for solid sphere, okay, into m. Okay, this is the potential energy. Now put u escape. Escape value from here. Okay, final, for final it will be final total energy is equal to zero. Kinetic energy will be zero, maximum height at maximum height, and it's about minus g m into m by r plus h. So r plus h, okay, where h is the height, h is this height. Okay, so this is the equation 1, this is equation 2. This is equation 2. Equate 1 and 2. Okay, half m u square will be 2 g m by 99 r by 100. Okay, this is u plus minus gm by 2r cube. Okay, 2r cube minus 99 r by 100 into m. Okay, this is equal to minus g m by r plus h. Now calculate h from here. Okay, and this will be like 99.5. So that's all. We have completed gravitation, full syllabus of gravitation, previous year IIT-JEE questions, complete explanation of all the theories. So now I think you have enjoyed the gravitation, this lecture of gravitation, and you will practice more IIT-JEE previous year questions. So that's all. Thank you. Here at Ask IITians, you can ask your queries and doubts. Only you have to do is you have to go to www.askiitians.com. On the website, you will find a tab as Ask a Question. Click on tab Ask a Question. A new page will be open, and on the discussion board, right side of the screen, you will find Ask Expert. Under this section, you have to select your categories from which your questions belongs. For example, thermal physics. Now you have to type your question here, or you can attach the snapshot of your question here, and after that you have to click on get answer. We will get you revert within 24 to 48 hours. So students, this is the end of lecture on gravitation. We have discussed about gravitation in detail from the concept point of view as well as from the numerical point of view. We also solved so many questions on IIT-JEE previous year. Now we know why planets orbit around the sun, moon orbits around the earth. We also know the concept behind the formation of tides. Yes, of course, these are all due to the gravitation. So, thanks for watching this video. For further video of physics, chemistry and mathematics, stay connected with Ask IITians. Thank you.